Welcome guys to today's video. Here comes another series of challenge which reads a to the power of b minus b to the power of a is equals to 17. So we are looking for the possible value of b and a. So please, if you are new here, kindly subscribe, and by the time you subscribe, please turn on the notification button so that you get notified anytime I drop videos on mass. So simply say solution in order for us to solve this. Solution. Okay, then write down the question which is a to the power of b minus b to the power of a is equals to 17. Okay, we are not having this, so we can simply write this to be a to the power of b, open bracket, close bracket, all to 1, minus b to the power of a, open bracket, close bracket, all to 1, which is equals to 17. Which is equals to 17. Okay, having this, recall my 1 is also equals to 2 divided by 2. So 2 divided by 2 is going to give us what? It's going to give us 1. So we can simply write this to a to the power of b, open bracket, close bracket, to the power of 2 over 2, minus b to the power of a, open bracket, close bracket, to the power of 2 over 2 is equals to 17. Okay, having done this, recall from a principle of indices which says if you are having a to the power of m over n is also equals to a to the power of 1 over n, open bracket, close bracket, to the power of m. So if you apply this true at this point, we can simply have this to be a to the power of b over 2, open bracket, to the power of 2, minus b to the power of a over 2, open bracket, close the bracket, or to the power of 2 is equals to 17. So the equation C remains the same, nothing changing, because if we put in this, it's going to cancel off this, and we are going back to this. And if you put in this two will cancel off this, so we'll go back to this. So it still remains the same. Okay, now what then is our next step? We say let a to the power of b over 2 equal y, and b to the power of a over 2 equal x. Okay, since we've done this, we can simply write this to be, so wherever we see a to the power of b over 2, we'll put y, and wherever we see b to the power of a over 2, we'll put x. So simply have this to be y all square minus x all square is equals to 17. Now the equation now looks more easier to work with. So recall a square minus b square is equals to a plus b, open bracket, times a minus b. Sorry, I'm using some identity similar to this, but don't confuse this for this. So we are having a square minus b square is also equals to a plus b times a minus b. So if you obey this principle here, we simply have this to be y plus x, open bracket, close bracket, or open bracket, y minus s, close bracket, is equals to your 17 is also equals to 17 times 1. So 17 times 1 remains 17. So we can put here to be 17 times 1. Okay, 17 times 1. Also note that x plus y plus x is greater than y minus x. So in other words, y plus s will be taking the big value, y minus s will be taking the smaller value. Okay, we are now having y plus s is equals to 17 and y minus x is equals to 1. So with this, we can solve this simultaneously using the elimination method. So if you should use the elimination method, we can put a We can draw a sign here, then say y plus y is going to give us 2y, right? Plus x minus s is going to give us 0, and 17 plus 1 is going to give us equals to what? Equals to 18, right? Equals to 18. So this is, we are having 18 here. Okay, so therefore our y is equals to 9. So if we want to look for value for x, we can say, let's pick equation 1. We can say y plus x is equals to what? Is equals to 17, right? Then we can make, I will know y to be 9, so we can say 9 plus x is equals to what? 17. Therefore my x is equals to what? 17 minus what? 9. So my x is equals to what? Is equals to 8. Is equals to 8. So the value of x is now equals to 8. So we know x to be 8 and y to be what? To be 9. Y to be 9. And recall we said y is equals to a to the power of b over 2, right? And we say x is equals to b to the power of a over 2. So we know our y to be 9, so we can say 9 is equals to a to the power of b over 2, and s is equals to 8. 8 is equals to b to the power of a over 2. So for us to find the value of a and b, we can simply square both sides. We can simply square both sides. We can simply square both sides of two equations, two values. So this, if we square this, we are having 81 is equals to a to the power of what? B. And we're having this to be 64 is equals to b to the power of what? Of a. B to the power of a. So if we have this now, so what then is the value for a and b? Okay, let's see how we can solve this. Recall, your 81 is equals to 3 to the power of 4, and your 64 is equals to 4 to the power of 3. So we can say 3 to the power of 4 is equals to a to the power of b, and 4 to the power of 3 is equals to b to the power of a. So by comparison, we can say b is equals to 4 and a is equals to 3. So let's see whether the value of a and b are correct by substituting the value of a and b into our equation. Recall our equation say a to the power of b minus b to the power of a is equals to 17. I will know our a to be 3 and our b to be 4, right? Okay, we can write this to be 3 to the power of what? Of 4. 3 to the power of 4 minus, what is your b? 4. 4 to what is your a? 3 is equals to 17. And 3 to the power of 4 is going to give us what? 81 minus 4 to the power of 3 is going to give us what? 64 is equals to 17. 81 minus 64, which is 81, 64. So 1 minus 4 is cannot. We can borrow 1 from here, making it 11. 11 minus 4 is going to give us 7. So you are left with what? With 7 here. 7 minus 1 is going to give us 7 minus 6. Sorry, 7 minus 6 is going to give us what? 1. So we are having 17 is equals to 17. So the value of a and b in this challenge is correct. So please, if you find this video useful and interesting, please don't forget to click on the subscription button and turn on the notification bell. Bye for now, and see you in my subsequent video. God bless you.